Hey guys, this is Nate Zapwaiter from Engineering Symbiosis AD coming at you with my second paper, which is essentially the Symbionics sphere paper, just stripped away of all of its artificial intelligence and computer science applications to recenter or refocus the main thesis of the theory around biogeochemical cycling, soft robotic, and living machine organ architecture. So before I rant on forever, I'm just going to let you guys listen to the text-to-audio reading. And yeah, because the recording I did last night was super echoey because I didn't use my headphones. So here I go.
On Symbionics, or urban ecological niche prosthetics, as the first architectural, an industrial application of the biogeochemical cycles. Sole author, Nathaniel M. Zapladar, June 3, 2026. First introduction. This research paper attempts to be the first technical white paper that describes the central concept of my overall body of theory or theoretical corpus on architectural and industrial applications to biogeochemistry and the biogeochemical cycles of the planet Earth. Symbionics, or urban ecological niche prosthetics, UENP. While the previous 17-page attempted PhD prospectus and founding Cunean scientific revolution paper, The Symbionic Sphere, Engineering. Biogeochemical symbiosis with the biosphere, January 2026. Not only attempted to map out the first known conceptual engineering roadmap of what an ecology, biodiversity, and biogeochemical cycle-based cybernetically integrated architecture, urban development, and retrofitting strategies could look and behave like. The 17-research-page prospectus on the symbionic sphere theory also attempted to conceptually bridge how computational infrastructure and artificial intelligence applications of Symbionics UENP, or Symbionic Engineering. Using the sole author's only engineering background in computer science, myself, and digital large language model surrogate-based experiments via Google Gemini to at least provide some empirical evidence to give the paper more intellectual and utilitarian weight, while trying to demonstrate its early theoretical promise. At the very least, by showing some empirical baseline to constrain the most ecologically destructive part of the electrical grid and global computer infrastructure. AI data centers, and server farms, in the hopes that the paper wouldn't be dismissed as just high-concept digital AI, art for alternative speculative ecological engineering or solar punk enthusiasts. The use of AI, aka Google Gemini, in the Symbionic Sphere theory paper was also intended to prove its tremendous experimental potential by using artificial intelligence LLM and ANN digital infrastructure. Due to its well-documented energy infrastructure strain and inevitable ecological deficits in community energy grid allocation, overall land coverage via already existing and planned expansion of AI data centers and server farms, communal water usage, and other tremendous ecological debts when considering the scaling of already pre-existing AI data centers' current mechanical forms. The Symbionic Sphere theory paper also utilized the data from these digital symbolic LLM experiments as some kind of falsifiable minimal baseline or empirical evidence, even if embryonic in nature. Alongside the author's severe resource constraint, working independently outside of any commercial or academic institutions, myself. However, because of the inherent dual nature of both central equations and perhaps most likely due to the lack of the explicit explanation of biogeochemical cycling architecture and industry, also being linked inherently with computer and artificial intelligence infrastructure and maintenance. As a theoretical and conceptual engineering extension of Vladimir Vernadsky's noosphere concept, that was meant to reflect the central biogeochemical architectural design theory of symbionics UENP. That is itself the application of Vladimir Vernadsky's biosphere theory, as outlined in his seminal 1926 The Biosphere. That is why this current paper attempts to address the pitfalls of that original symbionic sphere theory prospectus. Despite its objective, theoretical, and near-future experimental potential of the symbionic sphere paper, however scientifically and logically consistent with sound engineering principles, the Symbionic Sphere theory paper remains at the time of this writing in June 2026. The Symbionic Sphere theory paper will in all likelihood for the foreseeable near-term future will be continually dismissed for its highly interdisciplinary and intellectual polymathic nature. The unfortunate circumstance of this follow-up paper's framing is having to exclude the low-resource-driven digital LLM experimentation last February after writing the previous PhD prospectus on the Symbionic Sphere. in order to adequately reframe or re-emphasize the central thesis of Symbionics UENP, as the first theory to propose a biogeochemical cycling soft robotic organ architecture, due to the reliance on that particular resource constraint coupled with only engineering familiarity being in computer systems. Unfortunately, this paper has to rely purely on conceptual engineering theory to prove its validity outside of basic digital artificial intelligence experimentation. However, the previous Symbionsphere PhD prospectus still remains nevertheless rooted in realistic scientific principles and real-world implementation strategies, all of which at the time of writing last January of 2026 was still objectively based on scientific and engineering principles as well as already pre-existing technologies. That if the author of this text had access to some kind of adaptive or augmented ecology or environmental architecture design space or laboratory, the validity of Symbionics UENP could easily be proven experimentally beyond the digital sphere. Finally, before concluding this introduction, it should be specified and clarified that beyond schematic image generation due to the lack of traditional KD-based software, being incapable of adequately simulating micro then macro ecologically niche integrated architecture and industry through biogeochemistry and microbiology, the use of AI is now only strictly confined to detailed schematic image generation. It should also be clarified that my body of theory is not dependent upon artificial intelligence, either to run the nervous system of the proposed biogeochemical cycling integrated architecture and industrial designs. Lastly, although it was not explicitly stated in the Symbiotic sphere theory prospectus written last January, it should be clarified that insofar as computer infrastructure and artificial intelligence is concerned within the body of theory of Symbionics UENP, that the digital and artificial intelligence applications should be seen as the literal noospheric information layer of a future symbiotic engineering or symbiotic sphere. End of introduction. Abstract. Traditional, sustainable, biomimetic, symbiotic, metabolic, along with other forms of ecologically or environmentally adaptive and circular economic participating architectures. Despite representing advancements in architectural energy usage, via electrical grid load reduction through energy optimization and reduction in overall carbon footprints, alongside acknowledging some of the notable advancements in urban and electronic waste to resource conversion or management. However, this paper will attempt to theoretically demonstrate that without a central bionic or prosthetic mechanical means to participate in the biogeochemical cycles themselves on an organic matter, energy, or even basic thermodynamic levels of exchange, any such currently existing environmental, ecologically adaptive, symbiotic, biomimetic, or ecosystem biomimetic-based architecture designs and urban implementations. All of these cited examples of environmental architecture in the view of this paper then will remain functionally aesthetic rather than ecologically regenerative. Objectively, in any meaningful scientific or engineering measurable or empirically meaningful sense of the word, ecologically adaptive or augmented architectures are rendered energetically and materially inert without the facilitation of living for organic chemical mediums for osmotic exchange via biochemistry, geochemistry, biogeochemistry, or even microbiology in our case, in order to act as precise ecological and environmental markers or physical indicators of achieving active ecological integration between wildernesses and urban environments like small towns and full-scale major cities. This paper will also show how Symbionics UENP, as a conceptual engineering approach of turning the same urban environments that are the largest destroyer of natural habitats by global surface areas, be it terrestrial or aquatic in nature. Symbionics or Urban Ecological Niche Prosthetics UENP, as the only so far known mathematical and physical, spatial, and logical solution to regenerating the same ecological biomass in spaces that disrupted biodiversity and natural habitation, e.g. exactly or nearly exactly equivalent in surface areas and biomass density of those same pre-developed natural ecosystems, e.g. the global surface areas of the displaced or removed biomes and ecosystems, removed or spatially displaced by newly developed and well-established urban spaces. First, the biogeochemical cycles, as the central prosthetic or bionic link between, all built in natural environments. The first theoretical blueprints for ecological, syntropic industries and nonlinear cyclical urban development. Before attempting to outline a conceptual engineering approach for biogeochemical cycling architecture, urban development, industry, and energy production. This paper will scientifically and historically briefly expose the two most fundamental flaws of the sustainability sectors and biomimicry ecosystem biomimicry practices as applied to real-world architecture examples in the Biomimicry 3.8 based framework. 1.2. The biogeochemical cycles as the major knowledge, technical, and engineering. Blind spot in almost 3 decades worth of sustainability, metrics, and development. It is in the view of the author of this paper that sustainability has suffered from the dual compounding crisis of scientific unspecificity, rooted in the concept of sustainability's inherent lack of basis in the natural sciences. This lack of scientific and engineering unspecificity is continuing what some linguists and linguistic anthropologists have called linguistic decay. If this is arguably the case, then, it can be argued to be the case due to the lack of a unified definition of sustainability and sustainable development across all industrial, energy, and information sectors, including the biomimetic architectures. Biomimetic architecture has become relatively renowned ever since Janine Benyus's seminal work, Biomimicry, Innovation Inspired by Nature 1997. However, putting aside sustainability and biomimicry's lack of etymological roots in the actual natural sciences and non-unified baseline definition for all technological and urban, extractive, and manufacturing industries fields, there is no evidence of involvement of researchers in the biological or ecological fields beyond industrial and urban impact assessment post-development comparative analysis, which comprises a large body of metropolitan development and social impact literature. In other words, researchers and experts in the natural sciences usually aren't consulted, if at all, given that natural scientists are often in opposition toward continued urban expansion into the remaining natural ecosystems, outside of what the pre- or post-development of a given site's ecosystem impact estimation and post-biome ecosystem damage evaluations. It is worth noting that many, if not arguably most of the studies that employ the metric of ecosystem services as the primary marker for measuring the ecological impacts of pre-developed urban sites often shows the tendency to fall short of their post-developed urban sites' ecosystem goals, arguably due to the fact there's no apparent or clear strategies of how biomimicry and ecosystem biomimicry-based architecture and urban design, e.g. no physical, special, ergonomic, or energetic, means to house or actively augment large-scale ecosystems in built environments. In order to have the architecture purify air, water, soil, etc., it is the primary view of this paper, and the entire body of theory I have developed over the past 12 years, that it is most obvious that sustainability and biomimicry have tremendous knowledge gaps or scientific engineering and general conceptual blind spots to biogeochemistry and the biogeochemical cycles, also known as the planetary cycles. In the literature of biogeochemistry itself, the effects of urban and industrial development are well known and documented. Biogeochemistry, an analysis of global change. William H. Schlesinger and Emily S. Bernhardt, 2020. Alongside the Soviet-Russian-Ukrainian founder of biogeochemistry, Vladimir Vernadsky's seminal work, The Biosphere, 1926. So far, no conceptual or physically implemented forms of biomimetic architecture, or so-called symbiotic architectures, has even accounted for a physical or ecological metabolic connection, be it directly or indirectly, with their local ecologies and biomes. In other words, no long-term or near-term strategies for conceptual designs to account for, or no less partake in the natural biogeochemical cycles of Earth. This has led to even the most advanced forms of biomimetic, metabolic, or symbiotic architectures still displaying the characteristic of the same static one-way, ecological parasitic relationships with their respective surrounding local flora and faunas, as well as often overlooked microbial ecologies. Taking two real-world examples of biomimetic architecture into full view, i.e. the termite mound-inspired building, the Eastgate Tower in Zimbabwe, and the iconic super trees of Singapore. Despite both examples being real-world tangible advancements in ecologically benign architecture and built environments, they both merely represent a more ecologically benign form of resource optimization still linked to linear economies connected to global fossil fuel and hyper-extractive-based global supply chains. First, taking the termite mound building in Zimbabwe, for example, while the building ecologically regenerate. First, taking the termite mound building in Zimbabwe, for example, while the building itself has been able to optimize airflow and thermal ventilation. The termite mound building, however, lacks any inherent or technical means to actually purify or ecologically regenerate or participate in the air or oxygen cycle of the surrounding ecosystems. This leads to the same negative effect, i.e., air cycle deficit on the local oxygen or air cycle inside of the built environments and its immediate surrounding natural environments. That would characterize any other standard non-biomimetic architecture or buildings. Second, the artificial biomimetic super trees of Singapore. Despite representing a potential massive advancement in vertical urban agriculture and horticulture via rainwater collection and solar energy usage, the super trees still lack any inherent prosthetic or bionic means to architecturally or industrially participate in the biogeochemical or planetary cycles, which over time could diminish the Garden by the Bay super trees of Singapore's ability to integrate the harvesting of rainwater due to no apparent connection between any natural surrounding wetlands or miniature or large-scale aquatic ecosystems. Alongside the fact that standard photovoltaic solar panels lack any inherent means to participate in the solar cycle, leading to losing the majority of potential solar energy being lost as outwardly radiated thermal heat. Instead of using the solar thermal heat as a means to capture more potential solar energy, by using materials and design strategies that could actively integrate solar energy capture and even artificial photosynthesis with the natural surrounding solar cycles. Second, Hans Karl von Carlowitz, 1713, concept of Nachhaltigkeit as the extractive, industrial etymology of the term sustainability and the paradox of modern circular economics. It is evident when studying the etymological root of the modern term sustainability and its usage across the natural sciences as a reference point for ecologically benign or restrained development goals and metrics across differing fields of science and engineering, that the current scientific and no less economic discourse centered around sustainability and sustainable development, that the sustainability sectors are historically blind to their own roots in the 18th century Prussian, then German forestry and mining national or state-based industrial administrative or accounting management tools that Nachhaltigkeit represented. That is to say that von Carlowitz's 1713 treatise, Sylvicultura Oeconomica, represented an attempt to achieve the more long-term, efficient extraction of natural resource management for Prussia, then the later German Empire's national industrialization. In order to compete with the established British Empire and the rising power of the United States on the global market in the 19th and 20th centuries. In Prussia, then later 18th century Germany's case, it was a sober industrialist realization that typically characterized the view of the natural world in the Victorian age, that their national industrialization strategy was rapidly deteriorating the commercial viability of the timber forests for use in such things as wooden shafts for silver and iron mining. In order so that the then German Empire, before the onset of the First World War, began to industrially outcompete the British Empire by using a large, scaled-up version of what Hans Karl von Carlowitz called Nachhaltigkeit, or sustainable yield, roughly translates in English. Nachhaltigkeit and Sylvicultura Oeconomica laid the groundwork for Germany's and then other nations like the United States and even the Soviet Union's model of industrialization, as its logic then transcended just old Prussian, Saxon, and then German imperial borders, where the industrial policy of its day originated. While this specific forestry management methods did undoubtedly improve wildlife conditions for certain native animals and plants in Germany, this industrial accounting methodology from 1713 should not be confused with active ecological preservation and ecological restoration for its own sake. Nor was Hans von Carlowitz's 1713 industrial treatise meant to create technologies, industries, or architectural or urban living spaces, cities, towns, for the benefits of the biosphere and all of its occupants, including, of course, humans as well. Nachhaltigkeit, or sustainable yield practices, may have prevented the immediate ecological collapse of the German forests, like the Black Forest. It proves entirely ecologically insufficient for long-term biome or ecosystem regeneration desperately needed in the 21st century, especially when carefully considered against the backdrop of the dire acceleration of the global warming or climate change crisis. biodiversity and habitat loss crises, which are all effectively compounding the effects of the other into a series of negative planetary feedback loops. E.g., biodiversity loss exacerbates and accelerates global warming, while global warming accelerates and compounds biodiversity loss, both aquatic and terrestrial. This is also historically evident in the biodiversity and biomass decline of the German forests in the interwar periods, that did not see any form of major ecological bounce back through conservation methods until after the Second World War, roughly beginning in the 1970s, with the onset of the environmental movement of the late 1960 SS and 1970s. It is no wonder then that all major extractive and manufacturing industries, since the declaration of the compounding crises of the greenhouse effect or global warming or climate change, alongside, most alarmingly, the declaration of the sixth mass extinction or Anthropocene that has become designated as an official geological epoch. After decades of environmental activism and direct action by concerned citizens and even predominant environmental and ecological scientists for decades, this deep ecological critique of private, unregulated free market and state-guided industrial capitalisms, i.e. critiques of linear, hyper-extractive and major industries like the auto industry, for example. It is no wonder then that the car manufacturing corporations have finally committed to a full electric vehicle production global market rollout, although a deep sociological or socioeconomic analysis of the sincerity of the extractive and manufacturing industries, the auto industry's switch to large-scale electrification, as an example of a socially concerned institutional mechanism of self-corrective practices. However, given the fact that this sudden, characteristically expected commitment to full-scale electrical conversion of all vehicles and transport production only just arrived on the heels of decades of resistance to electrification of vehicles, now being hailed as institutional and socially responsible proof of a corporate institutional mechanism also referred to as the invisible hand of Adam Smith. Whether or not the ideological, not inherently scientific formulation of the invisible hand concept of Adam Smith is the actual basis of that supposed proof of institutional self-correction to offset the historic impact of the fossil fuel-powered auto industries, admittedly lies beyond the scope of this paper. It is still the view of the author of this paper that the sudden widespread adoption of the global market to electric vehicles and lithium-powered cars has more to do with continuing and maintaining the profitability of existing industries and their capital markets, then resolving their industries and corresponding global markets' real and increasingly measurable ecological compounding destruction of the biosphere, that the automotive industry's own tremendous contribution to that same global natural destruction, as well as most notably and obviously those respective industries and global markets' effect on downward spiraling global ecosystems and natural biogeochemical cycles. While a deep socio-economic and political economy analysis of the current state of the circular economy theories and its overall economic viability and feasibility is beyond the scope of this paper as well. When looked at purely through the lens of the natural or ecological sciences, specifically biogeochemistry and ecosystem sciences, it is also clear from an objective, biological, ecological, and an even purely thermodynamic standpoint that any economic system based on material matter, energy, or information loops, e.g., any economic system, regardless of its ideological foundations, at least since the advent of the industrial and scientific revolutions, that all economic ideologies have so far remained extractive and linear in form. For the utility, mechanical, and industrial expediency of producing material, energy, and information systems of mass production and its unaccounted industrial waste, that is merely relegated as just simple economic externalities, i.e., plastic pollution, macro and micro, acidification of the oceans, lead and heavy metal pollution, floating garbage islands and massive landfills still continuing to be expanded, the mass bleaching and die-offs of coral reefs, etc. It should not be surprising then, given the ideological and historical makeup of all past and current economic systems, that any attempt to theorize or no less coordinate or actualize a functioning and self-regulating circular economy or circular economies, even ones that aspire towards maximum ecological optimization or sustainable benignness, in order to address something as regional as local food insecurity, that any such circular economy or circular economic theories that does not consciously or actively account for biogeochemistry or the biogeochemical planetary cycles on or at any scientific or engineering level or analysis. Without the carefully considered ecological, biological, or planetary means of participation, materially and energetically in the literal planetary cycles themselves. It is the carefully considered view of this paper that any such circular economic theories that inherently lack to integrate or conceptually overlook the only necessary hard physical, scientific, and/or engineering principles. In order to realize the creation of a literal material, energy and information cycles or positive feedback loops for communal ecological regeneration or bioremediation required for a truly functioning scientific circular economy, an economic system that doesn't inherently violate the physical boundaries of natural law, like the current global fracturing economic paradigm. A useful biomedical analogy in visualizing the irrationality of planning circular economies without a basic theoretical and/or experimental means of biogeochemical cycle integration. This would be akin to trying to make an artificial heart work successfully as a blood circulatory organ, while only allowing one-way blood circulation through the artificial heart while at the same time trying to use it. That same biomedical design layout as the very means to make it work as a fully integrated, wider part of the natural vascular and artery systems of the patient's human body. As the biogeochemical cycles provide the only nature-emulating blueprint to disassemble all of the material and energy of production-based waste at every molecular level back into the biosphere. Despite the obvious engineering challenges that would present objectively, i.e. the biogenic flows of molecularly and atomically disassembled molecules and atoms moving back through the biosphere. Symbionics, UENP, and the symbiotic sphere then should epistemologically be placed within the intellectual legacy of the biosphere and noosphere concepts, where all symbiotic or urban ecological niche prosthetic systems act as the conscious engineering layer or osmotic skin of the geological force that is life, that Vladimir Vernetsky readily identified ahead of his time. Third symbiotic building envelope, retrofitting, S-beer grafting, the central core. Engineering strategy of Symbionics UENP. Why a unified soft robotics, living, machine and aeroponic, hydroponic, aquaponic, and indoor urban agriculture. System approach to naturally linked artificial internal biogeochemical cycles. The central core methodology of the conceptual engineering framework of Symbionics or urban. Ecological niche prosthetics UENP relies on the simple but revolutionary idea, conceived around the central methodology of using soft robotics and soft mechanics as the basis to build literal biogeochemical, geochemical, and biochemical organs for buildings to participate in their natural surrounding biogeochemical cycles for urban biodiversity restoration. Using a combination of carefully engineered and specifically adopted modular urban agricultural systems, hydroponic, aquaponic, aeroponic, composting, etc., indoor farming and living machines as developed by Dr. Nancy and John Todd would allow any future symbiotic UENP engineer or architect with a robust low capex method for rapidly improving the ecological stability of modern cities and towns. This synthesized tripolar engineering approach not only dramatically lowers the cost or capex of fabricating entirely new ecologically participating buildings, that doesn't rely either on new material science fabrication breakthroughs in order to create new symbiotic UENP buildings or their foundations. The experimental and implementation strategy of this theory does not need entirely new, undeveloped natural spaces to begin building architectures that can achieve a direct and sustained biospheric integration between natural and urban spaces. Soft robotics or soft robots are far less energy intensive than standard, purely mechanical robots and robotics due to their reliance on more passive energy-based modulation components. Air pressure valves, silicone gels, water or sand for soft robotic muscles, or moving robotic appendages, etc. Although the reader is probably used to thinking of robotics for dynamic and moving tasks, the idea of using soft robotics or soft robots as the basis for biogeochemical, biochemical, and geochemical cycling may seem counterintuitive justifiably. However, it is the carefully more than a decades-long attained research position of the author of this paper that soft robotics are the perfect and ideal basis for a two-tiered system of urban agricultural combined living machine conjoined soft robotic skeleton of a building. The adaptive engineering advantages of soft robotic systems as the foundation for an internal artificial biogeochemical cycling building organs. Due to the soft and flexible material nature of most soft robotic chassis and appendages, this makes soft robotics or soft mechanical systems more than ideal for adopting to each city or town's specific topography, geographical, or urban grid layout. When soft robots or soft mechanical systems are combined with urban agricultural aeroponic, hydroponic, and aquaponic systems alongside living machine soil and wastewater management systems, it creates an almost rough and ready engineering schematic that can go like this. First, aeroponic systems plus living machines plus specialized soft robots for air purification and circulation, connected to building via HVAC systems and other external and internal points of air and oxygen ventilation. You'll a start or basis of an internal artificial naturally linked built environment's air or oxygen cycles. Second, hydroponic systems plus living machines plus soft robots specialized for soil, nutrient, and water circulation. You'll have the starter basis of an internal artificial naturally linked soil, sediment, and nutrient cycles. Aquaponic systems plus living machine wastewater systems plus specialized soft robots for water and aquatic nutrient cycling. ELO's the starter basis for an internal artificial naturally linked hydrological or water cycle. Biogeochemical cycling, soft robotic organs for buildings and homes, Tier 1. The main biogeochemical soft robotic organs that deal with cycling the water, air, soil, solar, sediment, and nutrient cycles. Biogeochemical cycling, soft robotic organs for buildings and homes, Tier 2. The second tier of soft robotics, modulated with living machines to act as terrestrial and aquatic microbial ecosystem housing units. In order to monitor the specific health of the terrestrial and aquatic microorganisms as the main or primary biogeochemical, geochemical, ecological, and environmental markers to measure the ecologically regenerative metabolic flow rate of biogeochemical cycles between the built and natural environments. Final section, the central symbiotic equation for natural urban biogeochemical symbiosis. Static and dynamic state variations. The central symbiotic equation for natural urban biogeochemical symbiosis is the first attempt to use the descriptive language of ecological mechanics to classify a new form of ecological architecture and thus industry. It integrates biogeochemistry and biogeochemical cycles as the primary metabolic fluid between the built and natural environments that comprises the way that all urban and industrial systems would participate in the biogeochemical cycles, is the metabolic fluid of microecologies and microorganisms. E.g., you don't have to cycle an entire Canadian goose or flock of geese through a building back to its natural surrounding environment to restore the native ecosystems of Canadian geese. You primarily just need the correct microbial ecosystems and corresponding co-evolved microorganisms that support the maximum known health variables and vectors for Canadian geese's native ecosystems to achieve ecological remediation of its degraded air, water, soil, and nutrients in the form of consumed biomass, etc. In this way, then, the central symbiotic equation is the first scientific and mathematical attempt to describe not just an ecological prosthetic or bionic connection points between buildings and their natural ecosystems. Most importantly, the symbiotic equation for natural urban biogeochemical symbiosis in both its static and dynamic states or variations. The symbiotic equation for natural urban biogeochemical symbiosis represents the first known public scientific and engineering attempt to move what has often been called symbiotic, metabolic, even most recently and especially exemplified in biomimetic architectures. As outlined in the previous pages of this paper describing the functional and non-dynamic morphological characteristics of all biomimetic buildings, citing the real-world examples of biomimetic 3.8 architecture having the same or identical ecological deficits as all other non-biomimetic architecture. It is therefore the final conclusion of this paper that biogeochemistry and the planetary biogeochemical cycles are the only way for ecologically adaptive and any future ecologically integrated architecture to move beyond mere aesthetic and technical metaphors. Closing statements. Living matter is the most powerful geological force. Vladimir Vernadsky. It was the core aim of this research paper to demonstrate how by converting the same urban spaces that encompass our cities, towns, villages, hamlets, etc., into a highly reliable, theorized, retrofitted, and modulated sites of biogeochemical, cyclical, biomass, and biodiversity regeneration centers using expanded urban ecology spaces, be it in or on rural farmland and wildernesses existing on the outskirts of cities or all other major urban centers. When the readers of this paper try to imagine humanity's urban spaces or major metropolitan centers of life transform from parasitic mass destroyers of Earth's living biosphere, be it on the land or in the oceans, seas, major rivers, or lakes, Symbionics or urban ecological niche prosthetics, when considered as a conceptual body of theory and science, ready to be tested and experimentally scaled up with the right partnerships, Symbionic engineering may one day be seen as just one of many alternative routes for advanced ecological technologies and architecture to alleviate the worst effects of the climate and biodiversity crises that are present. At their best, implementations are arguably only marginally slowing down the biodiversity and climate approaching tipping points. It is the hope of this author that the theory of symbionics or urban ecological niche prosthetics is seriously taken into consideration in the not-too-distant future. Given the sheer existential gravity and the literal survival stakes of the ecosystem and biodiversity decline, climate, and other interconnected environmental crises. However, the theory of Symbionics UENP at the time of this writing is currently the only known fully unified solution capable of ecological regeneration through biogeochemical transductions, which is the only unified field theory for environmental science and ecology to temporally or spatially mathematically equivalent surface areas of our established cities and towns that are the only realistic, rapidly available to surface areas, be it terrestrial and aquatic, to repurpose as ecological regeneration zones that have removed the same or equivalent pre-developed ecosystems losses in biomass and biodiversity. That continues to push almost approximately 73% or more of the total global biodiversity that we have accounted for. This radical framework of environmental engineering called Symbionics or urban ecological niche prosthetics, UENP, not only takes some major theoretical or conceptual steps in attempting to address the question of how humans will continue to grow on or at any modern viable level as a species, while avoiding and trying to reverse the trend towards the already overreaching planetary boundaries of the biosphere and its biogeochemical cycles. By virtue of turning those very same established and developing urban spaces that are currently mass displacing the most species on every continent, fungal, plant, or animal, but also simultaneously addresses the question of where those same species may live. In this way, it is my hope that the readers of this paper understands that Symbionics, UENP, is more than just a theory of technosphere or noosphere iterative integration into the biosphere. Symbionics, aka urban ecological niche prosthetics, at its core thesis frames using biogeochemistry and biomedical technology design strategies to re-engineer our global metropolitan civilizations, or civilization with the lost wisdom of all nature, veneration, spiritualities, and religions of the ancient past. Figure 1.0, the central symbionic equation for natural urban biogeochemical symbiosis dynamic state. Figure 2.0, the central symbionic equation for natural urban biogeochemical symbiosis static state. Figure 2.1, the top picture is of my first whiteboard lecture on my central equation via Engineering Symbiosis AD. ESYM, symbiotic effective ecological integration of any urban structure or space. M plus E plus I, T E psol, the exchange rate of matter, energy, plus information divided by the specific timed biogeochemical cycle, interval TBCI as time variable, time. The TBCI is an engineering principle that also can function as the primary variable of this equation. The timed biogeochemical cycle interval, TBCI principle, is a theoretical method for preventing natural, elemental, and environmental erosion of a symbionic building or home's material and structural integrities, while at the same time preventing biological and ecosystem fouling that mirrors the metabolic rest that all natural organisms need to maintain internal homeostasis. CNBC, the conservation of natural biogeochemical cycles. R2 ill regeneration of conserved, ecological, restored, or bioremediated biogeochemical cycles in urban areas between wilderness and natural environments. NEC yield the ability of any given building to fulfill a positive or successfully regenerative function or integrated ecological niche between the urbanized and natural environments over time. TTBCI, ill-timed biogeochemical cycle. Interval, a soft robotic design and retrofitting implementation engineering strategy to prevent any given building or urban environments. Premature material degradation and structural integrity, compromise through organic matter, energy and information exchange over time. The timed biogeochemical cycle interval also represents a mechanical engineering and actual principles for a future. Symbiotic buildings, metabolic engineering function as translated from biology or biological principles. This strategy mirrors or emulates the natural metabolic rest that all organisms and ecosystems must partake in to prevent premature breakdown of the organism or ecosystem. The dynamic of this equation through the TBCI variant of the time variable of the central symbiotic equation also acts as the primary anti-biological fouling and microbial ecological fouling of the artificial internal biology, chemical cycling soft, robotic interior and exterior of any future natural and urban environments. This is the central equation underlying my entire body of theory of symbionics or urban, ecological niche prosthetics and all of my subsequent accompanying inventions and designs. It is the E=mc square of symbionics, UENP, the equation for natural and urban biogeochemical symbiosis, mathematically and physically describes through ecological mechanics that the successful integration of any single urban spaces or structures is directly proportional to the exchange rate of matter and energy and information divided by time it takes to exchange matter, energy, and information, or process data between built and natural environments. This engineering design principle also obeys the three laws of thermodynamics by accounting for and preemptively offsetting the potential for premature accelerated entropic degradation on any level. Figure 3.0, a basic visual schematic aid of an symbiotic UENP building or built environment concept in an urban sprawl or natural environment setting like a neighboring forest. Demonstrating urban to natural biogeochemical waste to resource flows. Figure 3.1, a basic visual schematic aid of a symbiotic UENP building or built environment concept in a SPBRR, symbiotic photocatalytic biofuel reactor and refinery. Design schematic. Figure 4.0, a standard design approach schematic for a symbiotic Yokta UENP, urban natural hydrological cycle, as the baseline for all future urban natural biogeochemical or planetary cycles. Evidence and material section. Zaplatar N. M. Engineering Symbiosis AD. 2026 May 15. Whiteboard session lecture video. 2 Symbiotic Biogeochemical, Biochemical, and Bioelectrical PLL video. Link. Zaplatar N. M. Engineering Symbiosis AD. 2026 May 7. Whiteboard session 1. The final iteration of the symbiotic equation for urban natural biogeochem sim video. Link. W.H. Schlesinger, Emily S. Bernhardt, 2020. Biogeochemistry, an analysis of global change. Academic Press. Vladimir Warsh. Vernadsky, 1926. The Biosphere. Springer Nature.
Okay guys, so as I mentioned before in my previous, when I switch the document over from Word to PDF, sometimes it changes the word alignment and the punctuation, so I apologize for that. And there was obviously just one more typo. There was an extra has that I missed in the Anthropocene sentence, and just spatial instead of special, but I'll clean up those errors, those last few grammar errors. If you guys want the full PDF or Word document, just let me know and I'll link it below. Alright guys, thank you for listening, if you're listening, and have a great night. Bye.